have 10 minutes on there, but I'm trying to do it in like 3 to 5 because we want to just play. We're here to probably play. We've all probably been at work today. So getting started is just going to be a quick for those of you who maybe have never even seen a microbit. Awesome way to come to this. That's amazing. I'm going to just really quickly show you what it is, the new features, and kind of what it does. But then we're going to, number 3, right away, start playing around. For any of you math teachers out there, you're going to love it. We're going to do a quick little probability coding. And that's just going to be an intro to kind of how the setup allows you to do tutorials. But then we're going to break away from tutorials and just get our feet wet in coding our own project, which is going to be something that I think we could all enjoy now, which is a hand washing timer. And then we're going to show how Microbit can integrate with TinkerCAD. If any of you have messed around with TinkerCAD, if not, that's great as well. You'll be fine. We're going to baby step it. And then last but not least, I'll show you some project examples, some that I have done, some that I have found, to kind of wrap it up and then let you play and ask questions. So on the right there, you'll notice Kelly's probably going to throw in the chat the link to the Padlet. This is links so that you can play along. So that first column there has all the links I'm going to be going to. I will try to make sure to go slow enough for you to, switch screens and whatnot. And then in the middle column, it also has some items to continue learning later. We only have so much time, but I wanted to give you things to kind of explore on your own later. And then that third column has project and event information, if you didn't get enough here. And then last, there's miscellaneous questions. So if there's things that are not getting answered right away that you want to throw kind of in that parking lot, Kelly will be watching the chat, as well as I'll try to watch the Padlet with her as well. And we'll definitely hit those up at the end. And then if you do not have a TinkerCAD account, that's okay. I don't want you to rush there now. I'll give you a minute to grab that. It's very quick and easy, especially if you have a Google account, but we'll need that at some point as well. So there you go.
And just so you know who we are and the voices that are talking today, I'm Kelly Ojeda. I'm the Director of Programs at Project Invent. We're a national nonprofit getting high school students inventing technology for social good. And then I'll let Maddie introduce herself.
Yeah, so I'm Maddie Lowry. I'm currently teaching at STEM School Chattanooga. I'm the Inventanooga teacher, which I'll tell you more about here in just a second, because that's not exactly the typical name of a teacher, but I teach seniors.
And lastly, I'll let Jordan introduce herself, another Project Invent teammate.
Hey everybody, my name's Jordan and I work with Kelly behind the scenes running Project Invent that we're about to learn about.
Awesome. Last thing, some people came in after I made this announcement. Long story short, if your name is Lamar Brown, feel free to change it to your actual name. That's my mom. It was a Zoom mishap. So sorry about that. It's nothing on your end, it's on our end. Awesome. Okay, I'm just going to take about 2 minutes of your time, tell you a little bit about Project Invent before we jump into the microbit stuff.
So do you want me to do this first, or do you want me to come back?
Oh, Maddie, I'm totally raining on your parade. No, I want you to do this first.
No, you're totally fine.
Wonderful host. Yes. Oh my gosh, please.
I really don't need to tell you a lot about myself. The reason Kelly and I talked about integrating this slide is because, so I'm currently working on my master's in STEM integration, and something that I notice in a lot of teachers is that they feel like they have to be experts in either microcontrollers or even just a microbit or digital fabrication, any of that, before they do it with kids. And so I wanted to talk really quickly about my path so that you can feel like that does not have to be true, which is what I would love for you to leave with. So very quickly on the left there, I started as a math teacher, and then my eyes were open to digital fabrication, and I wrote a grant to get the middle school that I worked at a digital fabrication lab, which we called the Twinovation Lab because we were the South Daisy Middle School twins. And I ran that lab for a year, having absolutely zero training. We got safety training, but that was it. So I had never touched a microcontroller. I didn't know how to run a 3D printer or a laser cutter. And so I ran that lab very successfully for a year with no training, learning right alongside kids. So working with some kids there to the right on a microcontroller, that was about December-ish. So we had already kind of figured out how to do that. And so that progressed into getting my job I have now, which is called Inventionuga. So it's very similar to what Kelly's about to talk about. I teach a class where kids solve real world problems by inventing a solution, which often involves microcontrollers. They often have problems that I don't know and I have never solved before. I'm pretty versed in obviously Microbit, or I wouldn't have been asked to do this, and Arduino, but I have kids that, need to use a Raspberry Pi, and that's not something that I've messed with a lot. So I wanted to say all of this to say it's a journey. Please start as soon as you're ready, not as soon as you're an expert, because the kids will learn more from watching you learn and being a lifelong learner than they're going to learn if you're the expert, because then you're the expert and you're the end of their learning. So you don't want that. You want them to see you learning right alongside them. So I just wanted to kind of put that out there. So you may ask me questions today that I may not know the answer to. I'm still learning right alongside my kids every single day. But I do know there's some pros in the house according to the sign up sheet. So feel free to jump in if you know something I don't know. We would love that. But I just kind of wanted to give everybody the ease of everybody. It's okay to start with your kids, even as a beginner. So, all right, there you go.
I love that, Maddie. It's so sorry to jump ahead. That's such a good journey. And I know there's probably a lot of people that are in similar shoes that you are. I think we already chatted through this, but please feel free to chat and interact with anyone, add questions in there. I'm going to do my best to keep an eye on it. Padlet is also a place where you can put parking lot questions and add your own resources if you have any about Microbit or invention or design thinking, anything that's kind of we cover. And the deck will be shared, and I'm just going to re-drop it in because I know, unfortunately, chat doesn't show up for people that join in later. Awesome. Okay. Here's my quick little spiel. So Project Invent is very similar to Inventionuga, except we're a national nonprofit and focusing on getting high school students inventing for social good. You can go to the next slide. And we really do this because we believe that every student should get an opportunity to be an innovative problem solver. We think that this is innate in students, that they naturally are, but they need to have real life experiences so that they can see themselves as innovative problem solvers. And the way we do this is we actually pair them with a real world community partner. So versus doing like the SDGs or like a big problem like pollution or global warming, those are great issues to solve, not trying to hate on those. But we find that when students meet someone and have a very intentional real life relationship, it helps them persist through the hard kind of gritty parts of invention and the design thinking process. So students have worked with people like Jimmy, who is he's a plane mechanic that's been recently blind, or like in the upper right corner, that's Jose. He's a classmate with cerebral palsy, and the Project Invent team invented him an adapted game controller so he could play Minecraft. And then Abigail, who's a practicing artist in the bottom right, she rocks a wheelchair. And so the students designed for her ways she can be more independent in her wheelchair. So we have students all across the country working with people like this. You can go to the next slide. So this is our program. So we teach design thinking. We teach students how to come up with an impactful idea rooted in the user, rooted in the community partner, not just what they think the person might need. We teach them engineering skills like what Maddie's going to show you all today, Microbit, and we also teach Arduino. And then lastly, entrepreneurship. Once you get a product, how do you make that scale? That's the flow of our 9-month program. It goes through the school year. And these are some of the cool inventions that students have done. I talked about the adapted video game controller, but they've also, they've made a smart steering wheel that helps prevent drowsy driving. They've made a smart watch for women to use to contact friends when they feel like they're in a threatening situation. These students, a lot of our students have never touched technology before Project Invent, and this is how they're ending the school year. Want to invite you to our demo day if you want to see what the students have been able to come up with through a COVID year. We still have students throughout this year participating, even though it's been a crazy year for all of us. I'm going to drop a link to the RSVP so you guys can RSVP to our demo day. It's kind of a drop-in event. You don't have to come for the whole thing. And we would love to see you there. And then next slide. This is at a glance what we do as an organization. We train teachers, we get students empathizing with clients, we get them building technologies, and then we give them an opportunity to present their inventions. And I just want to plug out there that we are trying to get into 100 schools this next school year. We are pretty much doubling. And so we're looking for people that are in here today that are teaching high school and think that this would be an opportunity that would work for them. Go ahead. And I wanted, this slide actually is a little harder to read than I thought. I wanted to invite you to join us. No matter what you teach, there's an opportunity for you to get engaged with Project Invent. So if you're an elementary or middle school teacher, any subject, you can join us at Infosys Pathfinders. We're doing a training July 18th to 23rd, virtual. There is a cost to the program, but I'll let you in on a secret. A lot of times that it gets covered by the Infosys Foundation. So you should definitely apply for that funding. And then if you are a high school teacher, we want to invite you to join our Project Invent Fellowship. We're taking applications up until May. So I'm going to drop a link right here for you guys to apply for that. Also, all these links we're dropping in the Padlet. So go to the Padlet if you're like, what was that thing she was talking about? Okay, I think that was it, Maddie. Do I have a few more things? Okay. I'm going to let you guys look at this slide. If you're interested in the fellowship, this is just more information about what it is and what you get. You can go to the next one, Maddie. Long story short, we have a free curriculum you can download on our website. It's a complete design thinking invention process for you to use. You can apply to come to our Pathfinders to learn how to use that curriculum, or you can be a part of our teacher fellowship where you just get a lot more support and you get events where your students can pitch their ideas, and RSVP for demo day. Awesome, my spiel's done. Now to the Microbit.
Yay!
The Microbit bit.
Yes, somebody put in the comments that Pathfinders is awesome. Yes, I joined Project Invent through Pathfinders last summer, and it was amazing, even virtually. So that says a lot.
Yeah, we
right. So let's jump in. Some of you may have never seen a Microbit before. So I have a big picture. It's just to give you kind of scale. It's very small, very tiny. I won't challenge any students, but I have found to be very almost indestructible. So if you have kind of some younger students, definitely still recommend Microbit. It's not going to be something that they can easily break. So if you currently have a Microbit of your own, you might have an original Microbit, which is what I have. Hopefully going to get myself a version 2 very soon. But if you buy one after this PD, because you're just so excited, fingers crossed, then you're going to see that they now have a version 2, which comes with amazing new inputs and outputs, which we're about to talk about. Both still have this LED display that's made up by the 25 little mini LEDs that are super versatile. The kids can make their name, make different emoticons, opportunities endless, honestly. But some of the new features that you're going to want to, get the version 2 for is it's going to have its own speaker, so you won't have to have the kids try to figure out how to hook up headphones to it, which is possible. And it also has a microphone. So today I'm going to teach you how to do something where you have a loud sound. That's only possible with the version 2, but you could always easily change your code to be like an on shake, because both of them have that accelerometer and can do the shaking or button switches, things like that. So just kind of a little bit, you can come explore this slide again later. So just quick thing about microcontrollers is a lot of the main ones that your kids and you would be playing with, like the Microbit, the Arduino, even some of the other just basic ones, I think little bits, things like that, they're just programmed to run over and over and over and over again, one process that you give them that just relies on an input and an output, or multiple, which we'll have today. But just that process of it's looking for something to happen from the world, button is pushed, and it's looking to see what you told it to do. So when the button is pushed, I show the heart. And I'm going to keep doing that every time that button is pushed. So microcontrollers are kind of simplistic in the thought that they will run something continuously, but it makes it very easy for you and your students to code. So some of the inputs and outputs that Microbit has is those buttons I was talking about. There actually is a temperature sensor. So for you science teachers, you can do this with weather, which is in the project ideas. It has its own compass and accelerometer. It has only in the version 2, like I said, a microphone and then the touch logo. So up here where you see this guy, that's now an external next button. So your version 2s now similarly kind of have 3 buttons. And then radio signals and Bluetooth pins. So both of these have these. They're just a little bit better in the version 2. One of the cool things I heard a PD did, which would be really cool if we were all together, is they made a bunch of microbits that they handed out. And then you had to push buttons to figure out and make them talk to each other and try to play up a matching game. So Kelly and I maybe both had hearts. And so it would be sending that radio signal back and forth, making the hearts go off, and they had to match them up. So they really are amazing little devices. Their outputs include, I couldn't list them all if I tried, because I'm going to show you how to link it to all of your other cool sensors that you can buy. But more so, readily, the LED display, the radio signals, like I said, they talk to each other. Add-ons that I'm going to show you, but usual feature is trying to add on headphones. And then you don't have to do that with the version 2 because it's now has its own speaker. All right, hopefully I'm not going too fast, but I was trying to get through kind of the nitty gritty so we can play. All right. So I think I did that in 3 minutes, which is, like I said, 3 to 5, guys. Okay, here we go. So if you could go ahead and open up your own Chrome browser while you're in this Zoom and go to makecode.microbit.org. And we're going to do a quick tutorial together. You can do these on your own very easily. You're going to see they're super step-by-step, but I want to show you some of the features that you can also highlight for your students. If you're a beginner, you're going to do the block code right along with me. If you're kind of I've messed with Microbit before and I kind of know what I'm doing, or you're a pro, I would push you to do it in Python or Java. And you can still do the tutorial even if you're well, I've never done Python. They now have tutorials for even those other things. So I'm going to go ahead and go out of here. So when you go to makecode.microbit.org, your screen should look like mine. So hopefully that was an easy transition. While I'm here and waiting for people to kind of move, I want to quickly show you that there are so many resources on this page. I chose the DICE tutorial because my math teacher side of me said, oh, I used to do a project where I had kids make their own probability setups that other kids had to play with and determine the probability. This would have been a great and easy way to integrate coding into that lesson. But there are a variety of tutorials, there are videos, all of these are kind of step-by-step ideas and games and things like that. But we're going to keep it simple for our first one. So if you guys would find the DICE tutorial, it should be right there on the front page. And then, like I said, if you're new, go ahead and do blocks with me. Otherwise, I would try Python or Java if you've already done block coding with Microbit. And I have the answers to all of these in the slide decks. So if you're I do blocks, but I want to try the other ones, you can always go back later because I've already given you the answers just in case. Okay. Oh, before I click this, some of them have video lessons. We're not going to do that, but you could do that on your own too. So click into there. Okay. So one of the things I want to show you that you can compare here in a second when we jump into Microbit on our own without having a tutorial is they minimize all of your options to only what you'll need. So if you were to do this with students, they're not going to be bombarded with an entire variety of different honestly possibilities. They're only going to have what they need. And then up top here, they're going to be given a step-by-step thing that shows them how to do this lesson on whatever it is that they're trying to do. So for us, we're essentially making a virtual dice. So like I said, we have to give it an input. It has to know what it's looking for. So it's going to tell me over here that I'm looking for the on shake. So if you go to inputs, notice I'll point this out again when we move. But normally there are a variety of inputs, but it's going to make it as easy as possible for students by only giving them what they need. So you're just going to drag it from here over. If I were to drag something I don't need, so for example, I may not need this on start, you can just drag it to the trash. So I have my input on shake. So it now knows it's looking for me to shake it. Like I said, it has the accelerometer. And then if you want to up here, you would just hit, okay, next, I'm done. So then oh, these are color coded. So that's also really nice. So it says get a show number block. So it's color coded blue and the basic was blue. So I'm going to drag this over to my on shake. So if I were to do this right now, it says when I shake it, show the number 0. The nice thing about over here is this guy will let me try it. So I'm going to click on shake and there's the number 0. So you can try it as you go to kind of see how your code is affecting the Microbit. All right, so then we're going to click next. And then it's going to let you pick a number randomly. So that's in math. And so notice when I drag this over, it shows me where I can put it. I can't put something like this into an input. That doesn't make any sense to it. So it only lets the student or you put it where it needs to go. So if I were to do this now on shake, it's going to give me a number between 0 and 10. But the next thing's going to tell us, well, we're trying to make a die. So we want to make it, and this is editable, 1 through 6. So hopefully you're playing along with me. If I am going too fast, feel free to put it in the chat and Kelly will yell at me and tell me to slow down.
I did have one person say a little fast, but I'm curious if we're good now. We might be good now. You can also put some thumbs up.
The transition was probably the.
Yeah. Cool. Also, okay, a little fast, maybe a little slower. I know you're trying to get through a lot, Maddie.
No, it's okay. I would like you to play along with me. So if I can go slower so you can play, that's perfect.
Awesome.
So hopefully, so just to recap, you have your on shake as your input then. You've gone to basic and you're going to drag over. I'm going to drag it just so I can show you that you can then take it away. Drag over into your on shake so it knows that you're pairing that input and output. And so I don't need this guy. That was a mistake. So I'm going to drag him to the trash. And then we went to math to find that pick a random number. So again, the tutorial is nice because it's only going to give you what you need. So I've changed my pick a number to be 1 to 6 because that's what would be on a standard die. And what you're going to notice is this is going to be plenty of code for it to know exactly what to do. So we actually don't need this forever loop. We don't really need this Microbit to do anything for forever. So I'm going to go ahead and take that away. It's not going to mess it up. I guess I should maybe, well, I can't put it back because I don't need it, but it would not mess it up for it to stay there because you didn't tell it to do anything. So it's going to ignore it anyways. All right, so we have on our shake, which a lot of times you can just, if you notice I'm like shaking my mouse over it, you can make the Microbit shake. The students would literally like shake it. Like I said, almost indestructible, but don't challenge them. Or if it's kind of finicky, you can just click this button up here and it imitates a shake. So every time I shake it, I'm going to get that random number. Are there any questions about this code? Because I'm going to jump into like our playing around rather than a tutorial. But I wanted to kind of show you how these tutorials will walk you or your students through up here. They have hints and they're only going to give you what you need. Are there any questions, Kelly?
I'm not seeing any so far. Great time to drop them in if you have any. One thing I love about the tutorials when I was getting started is that they do restrict, like you only see the blocks you're going to need. That really, really helps.
It gets a little overwhelming. Even I, who, you know, I love this and I do a lot of block coding. There are a lot of options, so it gets really overwhelming. So this is a nice place to start with kids.
One other question is, are the tutorials all based on version 1? We were getting some questions about like, should I get version 2? Should I get version 1? And we all in the chat kind of agree version 2 is nicer, but these are all version 1 tutorials, right?
I think so. They haven't updated a lot of them. I will say they have updated their tutorial videos, which I can maybe show you how to get back to if I can remember.
Sorry to interrupt you, Maddie. It makes me think maybe getting version 1 starting off isn't the worst thing because all of these tutorials align with them. So
that's true. Oh, here it is. So all I did, guys, was MakeCode is the coding platform. Microbit.org is just their website. So if you click this, take your first steps, it walks you through every single thing. And what I was talking about is all of these. So it walks you through the LEDs, the sensors, the inputs, outputs, all of that. All of these videos have been updated for version 2 because I went recently to check that. But I do think many of the tutorials, if I go back and just peruse, yes, these are all old, which, I mean, not that they're bad, but these have all been here a while. So those are going to be version 1. I don't see, yeah. But all of these are set up. So if you get a version 2, because you're like, well, I just want the new one and I don't want to buy 2, all of these videos have been updated so they can kind of help walk you through some of those differences and how to use them. And I can throw that, if it's not in there, I will throw that in there as soon as I'm done. But it's just the microbit.org. And then first steps, but I will throw that into the Padlet before we leave today. That's a great question though. Okay, I'm gonna switch back here really quick so I can show you. For any of you who, oh, I'm sorry, actually, while I have that up, I wanna show you one other thing. So if you are doing any of these that you're coding, you can switch and go to the, sorry, I'm gonna show you that one more time, if it'll let me. If you do it in blocks, so quickly going back for those of you I might have been going too fast for, you can also do those same tutorials. It'll give you those same step-by-steps in Python or JavaScript. So you kind of get those baby steps. So if you're like, well, I've done a little bit of Python, but I don't know enough to do all of that, that'll give you those step-by-steps to give you a learning point to jump off of. And I'll also show you a way to take your code, block code to Python here in just a second. Okay, but for those of you who might have done that, I put, for anybody who wants to go back, I put the answer there for that one. And then I've also put the answers for the Python and Java coding in this slide deck. So if you want to go back and play with those items, I highly recommend. All right, so Project Invent is all about, design thinking and solving real world problems that are affecting us. So I wanted us to do something that was not really set on a core class or, a certain subject, things like that, but something that would be super useful. So I actually have 2 teenage children. And what I would tell you is that even at that age, they don't know how to wash their hands. It drives me crazy. So I'm the, anal mom who's like, go back and do it for 20 seconds. So that's when I got this idea that we could build an interactive hand washing timer. So that's what we're going to code together today. And you're going to do this without a tutorial. So we're going to get to kind of see all of the amazing things that are options that you have. So if you go back to your main thing, so makecode.microbit.org. So exit the tutorial, it should take you right back here. I'll give you a second to come back. And if you're in the tutorial, you should be able to just click up here, right here, exit tutorial, and it should take you right back to the main session. And notice it's saving your codes for you, which is really cool. But if you switch computers, they won't be there because it does not ask you to log in like TinkerCAD does. Okay, so we're going to start our very first non-tutorial project. So click this purple guy here, and you want to give it a name. It's up to you. We're going to create. So kind of like give every a second to get there while it loads as well. Okay, so what you see on the left-hand side here now is notice there's a much larger variety of topics, for lack of a better term. And if you click advanced, there's even more. So the capabilities of Microbit are amazing. This is why I'm saying I'm not even 100% an expert, because there are things that I still have yet to be able to play with because there's so much. So it's well worth the money. Your kids cannot well, they can, but it's going to take them a while to outgrow it. But here we go. Let's get this started. So we're going to have to use something called a variable. So we're going to click make a variable. We're just naming an entity, and ours is going to be an integer. So if you were doing a different type of coding, such as the Java or the block, you would be designating this as an integer. But we're going to call this the timer. So make your variable. All right. Okay. So we're going to call on those in just a second. I'm going to move these over here so that when I pull that up, you guys can still see this. to kind of set our timer in block coding, we have to give it a start value so it knows what it's doing with it. So we're going to take this set timer and we're going to pull it over to on start. So on start means as soon as the microbit powers on, it's going to determine these items. So at start of the code, on start only one time, it's going to set that timer value to 20. So I'm setting it to 20 because that's the time we should wash our hands. And I'm going to, maybe mention along the way some cool ways to change up this code to make it more of a game. But for now, we're just going to do the bare bones. So again, this is going to happen one time on start. It's going to set our variable to 20. Then we need an input. So our goal here is to make it, what I thought would be cool is for a kid to kind of walk up and make it like a clapper. So back, you used to clap things on and off. So originally I always thought, oh, that would be kind of a cool thing for a kid to be able to just clap. That way they didn't have to touch it. So this is that empathy thinking that you would want kids to do. Why would we not want everybody to have to touch it to turn it on? That spread of germs. So I made it, okay, we're going to clap. So we're going to go to our inputs. And what you'll see if you scroll, and notice it has that nice designation there. So it's showing you that these guys are only for the version 2. So let's say you do have a version 1, you could do the same thing for a button, a shake, anything like that. But I was trying to do something you didn't have to touch. So our version 2 has that microphone that can listen. So we're going to pull over on loud sound. So my hope is that the kids would be able to clap loud enough to make this start. So this is our input. And so now it wants to know, okay, once I've clapped, what do you want me to do? Or once I've yelled at it, it doesn't really designate a certain type of loud sound. Over here, actually, I should have pointed that out. But when I pulled this over, this guy lit up to kind of show you, hey, you can test this out. So it's just going to know, it's a loud sound. It's not going to be able to designate clapping. So on this loud sound, I want it to do a couple things. I want it to count down so that the kid knows, okay, I'm washing my hands and counting down. I want it to show them when they're done, maybe with some cool emotion. And then I want it to stop and start over. So that's the code we're going to kind of put together. So we're going to make it count down. We're going to make it show like a cool little icon. We're going to make it stop completely, clear the screen, and start over. And I'll explain the start over here in a minute. I'm actually not going to need this forever loop. We're not going to ask it to do anything forever. So I'm going to just drag that to the trash so we have more room and organization here. Okay, so we need it to count down, and that's going to happen in a loop, for a lack of I should probably be able to explain that in a different way. So it's going to keep doing it for a set amount of times. So I want it to do that while it's going from 20 to 0, but then stop. So I'm going to pull over this while doing. Okay. Any of these loops, guys, you could play with this and try it out. And if it doesn't work, try a different loop. And coding is one of those beautiful things. You could code this a variety of different ways. I could probably code this to repeat -1 second 20 times, and it would do the same thing. It just didn't look as pretty as what I wanted. But there's a variety of ways, play around with it. And that's the great thing about being able to test it. So on a loud sound, while something is true, we're going to do what's in this box. What you need it to do is only do this from 20 to 0. Okay, so I needed to go 20, 19, 18, all the way to 0 and then stop. So I'm going to go over to logic. I'm almost positive. Yeah. So see, you'll get a little wait, where is that? Just click through the panels and you'll find it. There's just so many, but it is logic. Something else to point out is you can kind of see how these have those cornered edges, and some things have rounded centers. It'll kind of show you what can go where. So these guys would fit into this, and I can interchange those however I want. So I'm going to drag this over. And so I want to tell it while the timer is either between, so there's your logic, your math, right? While the timer is between 20 and 0, I want you to do these things. So I need to tell it timer. So you've already created that. So you have to go back to variables. And notice round area, round thing. You can pull that guy to the, nope, that first one. And notice that little red dot shows me where it's going to go. So while my timer is less or greater than or equal to.
Maddie, could you repeat the variables one more time?
Yeah. So variables are things that you're designating in code that can be named whatever you want. I could have named it a hippo, but it's just going to know that it's a number. Variables can be lots of different things in other codes, but for this block coding in this example, we made it a number. If I were to change this over to, let's say, Python really quick. And that's another cool thing while I'm answering this question. I can keep going back and forth from my blocks to these other coding things. I just cannot, I can't edit this in Python. If I start editing this, it will not let me go back to code. So just kind of keep that in mind, but you can keep essentially comparing, because that would be a nice place for you and kids to start as you go from block coding to other languages. You can compare those items with your blocks that are a little more layman's terms. So my variable is my timer. So it's just, I'm calling this number a name, which is timer. I think in, I actually probably messed that up. I'm sorry, everybody. In my answer sheet in the slides, I called it seconds. You can call it whatever you want. You're just giving a name to that value because that value is going to change. So it's going to count down that value. So as it goes, that variable is going to count down and it's going to be 20 and it's going to be 19 and it's going to be 18. It's going to be 17. So that value is changing and it just needs to kind of have those starting points of you're setting that value to 20. And then while that value is changing from 20 to 0, it's going to do something. So a variable is just like in math. X can be anything, but I have to name it X. Okay, does that make more, is that hopefully better? Feel free to tell Kelly, like, no, I still don't understand.
Got it. I think that was good. Thank you for going over that again.
Yeah, no problem. So again, sorry guys, when you see the answer in the slides later, that'll say seconds, but again, you can name it whatever you want. So I've set that to 20. And I need it to do something while it's greater than or equal to 0. So I want it to count down, but I also want the kids to be able to see it count down because that's probably going to motivate them. So you can tell it to show something on the screen. So notice I can tell it to show a number. So I'm going to drag this over. So while it's counting down, for lack of a better term, that'll kind of become more clear as we code it. While it's counting down to 0, show the number. Well, right now, it's literally just going to show the number 0. But the great thing is because I've designated that variable, which again can be any number, but I've put parameters in, I'm going to have it show that number. So I'm going to have it show the timer, which I can't quite test it yet because we haven't told it what to do with that number, but we're going to do that next. So in many coding languages, you're going to have pauses done not in seconds, but actually these milliseconds. But if I move it over, the great thing that it's done here is that instead of something like Arduino, where you just have to do the conversion and know, okay, 1,000 is 1 second, it actually turns it after you get up to 1 second, the kids will see seconds rather than milliseconds. But you could also just change this to be 1,000 to be that 1 second. Or if that confuses the kids, you can just do 1 second, but it will show up there as 1,000. So right now we have, while the timer is counting down, show the timer, wait 1,000 milliseconds or 1 second. That's because there's not really a function to just say count down. You have to tell it how to count down. So you're going to pause and then you're going to change, which I have to remember it's in variables. So we're going to change that variable because remember that variable can be any number. We're going to change it by -1 because it needs to count down. So really quickly, just so everybody's with me, while it's going from 20 to 0, it's going to stop doing this. So this loop here only happens if that value is greater than or equal to 0. Once it hits 0, it will bump out of this loop and onto what we're going to do next. So on the loud sound, this will keep happening. So what the computer inside of it is doing is it's saying, okay, what is it? Okay, it's 20. So do this, show it, pause, change it. It's 19, show it, pause, change it. Show it, pause. It's going to keep looping it until it hits 0, and then it's going to stop. We want it to do something else though, because right now, so notice there's my loud sound. The student just clapped. It's going to start counting down. So it's scrolling, and you can test that code for yourself. But when it's done, it's just going to stop. I mean, that's not very exciting for kids. So we want to put something in there that's like, yeah, you did it. So we're going to go over here to basic, and we're going to do a show icon. These are great because they already have all these preloaded icons. However, if you wanted to get fun and crazy, you can make your own icon by bubbling these guys in. So I can bubble it in however I want to. So the kids can make any picture they want. But I'm going to go ahead and just show icon. And I'm going to make it a smiley face. So they're going to see a smiley face. So kind of just to re-explain that loop, because now we don't have anything, we have something after it. It's going to do this all the way down to 0. But since it's still in this loop on loud sound, it's going to do this until 0 and then go here. So it's going to show that icon, a smiley face. And then, like I said, guys, we need to make it stop, like clear the screen, and then set it back to what we need it. Because right now that timer value is set to 0 still in the code. Because this on start, like I said earlier, only happens one time. If I were to put it in a forever loop, that's going to mess up what we're trying to do. So all we have to do to fix that is basic. We're going to let it show the smiley face, and then we're going to clear the screen. And then the kid's going to see the smiley face. It's going to go off. They're going to know they're done, but we need to tell it to start back over. So we have to set that timer back to 20, or set our variable back to 20, because it could have been seconds, it could have been hippopotamus, up to you. So you actually now have successfully made a hand washing timer. I'm going to very quickly, if I can, without messing it up, change this to something smaller so we don't have to sit here for the full 20 seconds for us to test it. But I can go over here and simulate a clap. So it's going to start counting down for, this is why kids don't wash their hands long enough, because it's painstakingly slow. And then we should see the smiley face, and it stops, and it starts it over. And you can play around with this. You can make it show more icons. You can make it, what I was thinking you could do if you were maybe a pro or somebody else who has been messing around with it, you could integrate that die code to this, and it could be a game. They could have to wash their hands from anywhere from 20 to 25 seconds. And every time it's a random number between 20 and 25. The possibilities are absolutely endless. So you can use those same codes that you did with the die to make this more of a game for kids to have to wash their hands for different amounts of time. Okay, I don't want to keep you guys longer than we're supposed to, and I still want to go to TinkerCAD, but this is really important because we're going to build off of this in TinkerCAD. So are there questions on this that I can go over again? I don't mind at all.
We do have a question of like, how did we make it go? Like, how did we start it? So maybe just explaining how you simulated a sound really quickly.
Absolutely. Yeah. So your Microbit, when you have one in your hand, is going to start, you have this little guy in the back on version 2. I believe it has an actual on and off button. I don't have a version 2, but I'm almost positive. But most of the time when you plug these guys in, they're ready to go. They're going to start your code, if that's kind of what you mean. But to test it here in the virtual setting, you have different options. So I can push this button. As you can see, I don't have it coded to do anything, so it's not doing anything, but everything's interactive. I simulated that loud sound by this guy right here. I can scale this up and down. So that's a really quiet sound, but I can simulate the clap by going, boom. And then it's going to take that as loud sound, and it's going to start doing what our code said. So you can do any of the different inputs to test your code right here in MakeCode. Hopefully that answered your question. But a lot of different microbits, guys, these Arduinos, once you plug it in, it's going to start looking in for and running that code.
And then just a good lead into the next section, someone was saying, oh, it should have like a sound at the end. So I feel like that's a great lead into what you were about to show us with TinkerCAD.
Yeah, it is. I'll show you before I leave here. There are sounds in here. If you have, you can do sounds with version 1, but you have to hook it up to headphones. Or there's not a headphone jack. That's the hard part. Unless, and I will go over this again when we go to TinkerCAD. There are things called Breakout Boards. This is my favorite, and I have it linked. It has its own headphone jack integrated already into it. But otherwise, you'd have to do it with alligator pins on your headphone jack. But you can do music here. And I could pull this over and say, I want it to show the smiley face, play the certain melody. So you can do that here, but we are going to show you a really cool way to do that in TinkerCAD. Before I leave though, there's one thing I want to show you that has nothing to do with our code, but a new feature. At least it's new to me because I never noticed this before. And then I got really excited. I'm going to pull over just a random, okay, so on shake. So something you're going to see when we go to TinkerCAD and we start using external sensors or external outputs is the wiring aspect of it. You have to wire things rather than it all just being within the Microbit. One thing I found really cool here is that if you were to start coding in this servo motors, so for those of you who maybe don't mess around with this stuff a lot, servo motors are tiny little motors that can either continuously or they can be programmed to just kind of do different angles, especially good math teacher, that'd be a great integration. But if I pulled over this servo pin and I said, hey, it's going to this pin, it's coded or it's wired it for me on the screen and kind of showed me how to wire that servo. And then if I were to have 2 servo motors and say, okay, that's going to be in pin 1, it's going to expand it out into a breadboard for me. I just think that's amazing. And it's such a great tool that kids will have or you will have, because when I first started coding with my kids, our first step was always look up a wiring diagram because we were still learning how to wire everything. It's kind of doing it for you. And it even highlights these different channels I'm about to talk about or the power, you know, it's all kind of interactive within Microbit now, which is amazing. But I am going to show you how to do a lot of this in TinkerCAD because it's going to expand the possibilities even further. But I kind of wanted to show you this to give you that view on Microbit. All right. So really quickly, I want to go back before we move on and show you later. I have this code in here. So if you want to mess with it again, you don't remember what I was talking about, I kind of have some of these things written out. Remember, I'm so sorry I did seconds rather than timer, but it's going to be the same thing. If you messed around with or want to mess around with the Java or the Python, I've also put those answers in there, just so you have that. But remember, before I leave, you can always go and look at those while you have the code there. So it has coded it in Python for me as I've done it. But if I click and try to edit it and try to do other things, it's going to stop letting me kind of go back and forth between the two because it'll have things in there that won't translate directly to block. So just keep that in mind. Okay, so we're gonna move to TinkerCAD. Hopefully some of you have heard of it. If not, or messed with it, if not, that's okay. Hopefully this is a super exciting experience for you. So if you could go to tinkercad.com, I'm gonna give you at least a minute on this, because if you don't have an account, it probably will make you make one and sign in. So it should be a quick, easy, just log in or sign up with Google. It'll ask you if you're a student, a teacher, or maybe just community member. Go ahead and claim yourself as a teacher. And then I'll wait just a second. Let me know if that gives you any issues. I haven't had to do that in a while, so hopefully I know. But then you'll have your own account.
That, Maddie, oh, I lost what I was saying. Oh, someone was asking for that partner, that Microbit partner activity you shared at the beginning. Is it written somewhere?
That's a great question. If not, if I could get that person's email, I could ask the person who told me about it. It is not something I did. It is something you can do. So if I can, oh, it's been a hot minute. Hold on, I have to remember where to find that. I have to remember radio. There it is. So the way they did it, this is what I know preemptively, and I can try to get you more resources on it. They made sure, so if Kelly and I were partners, our radio group was set to the same thing, but nobody else had that radio group. So Kelly and I were 1, Jordan and Deanna were 2, Karen and Lamar were 3. So that those 2 microbits are only talking to each other. And then they would send some sort of value, so that way that Kelly and I could see the same value back and forth, and we had to find each other. That was not something I did. It was something a colleague of mine experienced. And so I'm happy to see if I can at least find it or get that from her for you. But I just know that's possible. But that's kind of how they did it. You have to set the groups by the pairs. So you want to code them all beforehand. And then they were sending back and forth, maybe like a text, like hers and I's could say hippopotamus. I'm just really into hippos right now, apparently. And so we had to find the other person who said hippo. That's how they did it. I just don't know much more than that. I'm so sorry.
Brian said to check out the hot potato game, that it's kind of similar.
Oh, cool. Nice. Cool. I love when people can help out. Thank you guys.
Awesome. So everyone should probably have TinkerCAD pulled up now. If not, let us know if you're having any trouble.
Yes. Yours probably looks like this when you don't have all these crazy things that I have built, but yours probably looks something like this, or you have your own crazy things you've built. Over on the left-hand side here, you're going to click circuits. So TinkerCAD has a variety of circuits and ways to do that. Most of them revolving around Arduino, but they have now recently expanded to Microbit, which is amazing. So you want to probably be better than me at naming your things. Just so quick tidbit, just be better than me. But go ahead up here in the green and click Create New Circuit. And it's going to tell you about the new Microbit component, because this is something new for them and it is flawless so far, knock on wood. It's been really amazing. So this is kind of the next step for your students, because this is where they can use those breakout boards I was talking about. If you get I have it linked in there, an inventor kit. They come in like things like this from SparkFun, and they have their own breakout boards, battery packs, different things. So you can get the whole kit. And those items, like I said, that breakout board's not my favorite. I have a better one on there for you. But that's how they're going to use this Microbit to go ahead and breadboard. Or you can just breadboard with sensors, and that's what we're going to do today. So go ahead and pull over. You kind of do it the same way as the block coding for Microbit. You just drag things over that you need. So this happened to be in basic just because they're probably trying to promote it. But you can do, you can sort things by, okay, Microbit, or you can sort things based on, anything else if you want to mess around with Arduino, all of that. So if you click all, they're sorted by input devices, output, things like that, power. Okay, so we have our Microbit. Pulled that over. We're going to need to use a breadboard because I'm going to have to use some different sensors. So go ahead and scroll down. You can do a large one or a small one just for the ease of fitting it on my screen so you can see it. I'm going to pull over the small one. And when you go back to this later, if you have not breadboarded before, it's not difficult, guys. It's just about getting used to it. A very, very nice gentleman who has joined us tonight made these lovely things that I kept in the presentation for you if you want to look at them later. They kind of talk about how these are wired. So feel free to use that as a resource. But I'm just going to quickly explain it here so we don't run out of time. You are going to be able now to expand this out. This just allows you to essentially, one, prototype without soldering. So students can mess up all they want because it's just a pull of a jumper wire. But it also expands out how you use different ports. So I can now have endless, for any of you who have messed around with Arduino, you'll notice, especially like when you're using a board like an Uno, you run out of ground ports and power really quickly. So this allows you to take this and it's all ground. This is all power. These are going a different direction. So don't get too confused, because when I go here, these are going to go this direction. So vertical for you on your screen, depending on how you flipped your micro or your breadboard. But these all talk to each other. So this is all here going to be 1. This is all going to be 2, so on and so forth. They kind of work like a coordinate grid if you ever wanted to write it out for students, like 1A, B, C, D, so on. So as I plug things in, I'll kind of explain that more, but these all talk to each other. So you want those all to be the same pin. It's going to hang with me if you've never breadboarded, and I'll keep explaining as I put jumper wires in. Before we wire anything though, so somebody said, it would be great if this had sound. You were totally right. It would be great if it had sound. So we're going to go and find, have to find our outputs. So
sorry, Maddie, one quick thing. Can you model how to zoom in and zoom out?
Oh yeah. Okay. So you have a couple of different things. So I have a mouse with a scroll thing, with a scroll wheel. So you can do that. Or if you want, so also if you click out here in no man's land, you can kind of move it around. You can also center it on your screen. That was up here. Center it on your screen. And then I believe my plus and minus bar is hidden by all of the things. Hold on. Let me move this around. We can also scroll in and out. Where is the scroll in and out?
We got it. That helps.
Okay. So
thank you.
Yeah, no problem. So there should be a plus and minus. But you can also center it on your screen really easy. I'm going to just left adjust it, just because what's going to happen, guys, when we code this, if you push this out, that's going to be annoying when they're right next to each other. So I'm just going to left adjust it. Awesome. So I love the idea of it having sound. So if you go over here, notice to our outputs, that's what we want it to do at the end. We're going to bring over this buzzer. So it's going to be our ending sound. And I also was thinking in my head, I know as a teacher, with all of the crazy things happening in your classroom, every time a kid washes their hands, that you have to hear like constantly throughout the day, it's going to be crazy. So I was thinking, okay, how do we keep them from touching it and also keep me from getting a migraine from clapping all day? So if you go to inputs up here, there is actually a PIR sensor, and this is a motion sensor. So this is something they could wave their hand in front of to activate it. So now I don't have to touch it, and they can just wave at it and get it started. The very nice thing, and I'm actually going to set this up similar to how I have it in the slides, just so it's easy to recall. The nice thing about TinkerCAD that's not so true with, tech, like items right in your hand, is you don't always know what the pins are for, because sometimes they're not labeled. So like I said, I have kids look up a wiring diagram. But if I hover over these pins, it tells me exactly what they are. So this is where it's going to receive signal or send signal, because it's an input. And this is its power, and that's its ground. That's so nice. But before I go to wiring these guys, I'm going to wire my breadboard from this to at least do power and ground. So if you just click right here, it gives you a jumper wire. So I actually have some, if you have never seen them. When you actually breadboard, you just have these like cute little wires that you can just kind of poke in and out very easily. So that's what you're doing here. And I can take it, if you want to make it all pretty, you can click and it'll bend, and then click, so on and so forth. You can change the color, all of that. I like to remind kids that color doesn't matter with jumper wires, because for some reason they always feel like they must correlate everything with color, but whatever makes them happy. Okay, so now this entire row is acting as a ground, and I want to power it. So this is 3 volts right here, 3.3 volts, but take this, and I'm just going to go ahead and click it here, because, and remember guys, once I put it in one, this whole thing talks to each other. So now our board, at least this half, is powered. There's a channel here that does not talk to the other side when you get really into breadboarding. So if you wanted to use both sides, you just power this one too, but we don't need to do that. All right, so we have it powered. Now I'm going to take my ground on our sensor, and I'm going to bring it over and put it in the same ground row. And I'm going to start maybe actually color coding these for you, just so you can kind of see that. Hopefully you're playing along, and I'm going to try to slow down just a little. So then we need to power it, and that's going to be your positive. So think positive and negative, power and ground. So I'm going to take this over to positive. So now it's powered, but it's not understanding. I'm gonna make that one red. It doesn't really understand what to do with that data because there's nothing connected to that yet. So it inside is looking for that wave, but it's got to send that signal somewhere. So we're going to tell that signal. I could, if you wanted to, but we wanted to kind of show you how to breadboard. I could take that signal directly to a pin, but I'm going to go ahead and put it in one of these rows here. So I'm going to actually, here, let's make it a little cleaner. It's going to be in row 13. We'll make this blue. Row 13 now is all that signal. So no matter what I do, this entire row, every wire I put into it is the same as this port. So it's receiving that signal. So I'm going to click any one of these and take it to one of the pins so that it will talk to the microbit. So now the microbit will receive that signal when they wave. As long as I've coded it appropriately, it'll receive that signal and know what to do. So very quickly, we've powered it with negative, positive, and we have sent that signal to the microbit. We haven't got to coding yet, guys. So if I would turn this microbit on right now, it wouldn't know what to do. It doesn't know, you haven't told it what to do with that signal, but we're just wiring right now. So that's all we have to do for this sensor. So now we've got to get our buzzer.
How do you
wire.
change the color of the wire again?
Yeah. So you have to click, if you've already placed it, just click on it, make sure it kind of highlights those edges. And this is 3 volts. So I can up here on the right, you'll have wire and you can change it to any color you want. So a lot of kids, when they're doing the positive and negative, they want to make the positive red. Totally fine. Hopefully that helped. A lot of things will have a menu that pops up here. So if I were to use like a resistor, notice that's where my menu pops up to change the resistance value. So a lot of times if things can be edited, that menu will pop up to the right up here. Oops, sorry, I'm just trying to put, and if you put a wire and you don't want it, if you click, it's just gonna keep going. So if you don't know, like, wait, stop, just hit escape and it will go away. Okay, oops, I don't need this. Delete it. Delete. Okay. And now, so this is all wired. Now we need to wire our buzzer. Sorry, lost my. See, this is where kids will get a little confused. If I take this to positive and this to negative, that buzzer is going to go off continuously. It is continuously powered and it's just going to keep yelling at you. Piezo buzzers are very jarring, not going to lie to you, but they can be fun for kids. Instead, we're going to ground it. So you're going to take your negative and ground it. And again, if I click on my little guy here, I am so sorry. I can change it to whatever color, but I like to, again, remind kids, the color does not matter for jumper wires. I used to have kids in the lab run up to me, Miss Lowry, I need a red wire. You don't need a red wire. You want a red wire. So it's up to you. And then take this positive here. And the way you keep it from constantly going off is you only allow it to receive that signal when something has happened. For that to be true, the microbit has to talk to it and it has to do it through. So since we coded this one through the breadboard, I'm going to code this one not code it, excuse me. They're coded all the same. I'm going to wire this one directly to the pin, which you can do here. So there we go. I have wired it to the pin. So now I have this guy in pin 0, this guy in pin 1, and that's how we're going to talk to them. So that buzzer now is only going to receive that positive charge, that enough to go off only when we have it coded to say something to that pin 0, which I'm about to show you now. So hopefully yours looks relatively like mine. This is kind of ugly, but you can make it as pretty as you want or not. It will still work exactly the same, which is nice. Okay, once you have that coded, or excuse me, wired, if you go up to the top here and click code, because you've pulled a microbit, it's probably going to default to this block coding, which is great. You want that. It's way easier for children because you don't have to go through and find it. So The nice thing about going to Microbit first and then here for your students may be that we're going to use a lot of the same code. First, though, we do need to set those values again. So we want to make our variable. So remember, we're going to create that variable and you can name it what you want. So I'm going to name it timer again, just to keep it kind of the same for you guys. And just like we did last time, we're going to set that timer on start to 20. I'm actually going to maybe zoom out just a little bit here in a second. So because I need to fit it all. The only extra thing we need to do here is we need to write, it's digital write, which is essentially telling that pin to be something. We need to make sure these pins are both essentially off or low in the beginning. This is just a habit you probably want to get into as you code. So if I go to output, digital means on and off. So anytime you see digital pins, it's something that's on or off. So this buzzer is going to be on or off, and this PIR sensor is either going to see something or not. It's one or the other. If you see an analog, those can be multiple different varieties of things. So we don't need that. We just need it to be on or off. So that's a digital, and that's a whole deep dive. Definitely do your research on that because it's very fascinating. Okay, so we're going to digital write pin, and I don't want to run over time. Okay, pin 0, we're going to make sure it's off. So low and off, same thing. Pin 1, which is my sensor, we're going to tell it, hey, this is off. We haven't touched it. We haven't messed with it. It's off. Okay. This is just nice standard procedure. So it knows the variable is going to start at 20. It knows pin 0 is on low currently, and it knows my PIR sensor is on low as well. Now, we want it to, again, still do the countdown, but now instead of an on clap or on loud sound, we're going to do if this senses motion. There's no block for it. If your PIR sensor senses motion, that's if that sensor is high, which means it does receive a value. It's on. So we're going to go to the control first because we need to loop that. We need to tell it if this is happening, we want you to do this. So this is where I'm going to introduce you to the if else loop. So down here at the bottom, so I went to control and I'm going to move over if else. The reason I'm going to do this is because I want it to do one thing if the sensor goes off. Otherwise, I want that buzzer to not make a sound. Okay. So we're going to do the if this is on. So notice up here that said off. So we need to do if that is on. Okay. So we're going to do if we're going to pull over the, sorry, I'm looking for it. My brain is, if the P1 is high. So we want that to be, if we don't need and, we just need, I don't know if I need that is. Hold on, sorry. I want to find the right one. Oh, here we go. Sorry, it was in input. So if, so right here, I'm dragging down here, input. I'm going to tap it into this guy, which I don't think this is. So I'm going to have to go out just a little bit because I don't think this lets me. Oh, it does. That's amazing. It does let you expand. Okay. So if you need to make sure the right pin though. So our PIR sensor is done to pin 1. So if pin 1 is high, so if pin 1 is on, if somebody has waved at it, I want you to do something. So we have to do that loop of while it's counting down, but unfortunately in TinkerCAD, it's going to be called something a little different. And so it's going to be repeating while something is happening. So I'm going to say that again, because this is the little kind of confusing part. When I wave at the sensor is what this says. When this is turned on, repeat while the timer is counting down. I want it to keep doing the same exact thing over and over again. So we're going to do that timer is greater than or equal to 0 again. So we're going to pull this guy down here. So while, go find your variable, while the timer, so remember that was in variables, is greater than or equal to 0. So while it's still counting down, I want it to show, because remember, you still have to tell it to show that number. So I want it to show, it's the same as what we just did in MakeCode. And then I need it to show that value, that variable, because remember, that's a changing variable. So I need it to show what it is in that moment. And then I want it to change that by -1. I want it to count down, but it still needs to have that pause, because otherwise it's literally just going to count down. So we need to tell it to pause for 1 second. I think that's under control. Yep. Wait for 1 second. So if my PIR motion sensor goes off, I'm going to repeat this set. Notice it kind of lumps it all together, this set of code, until this happens. So I'm going to show the number, count it down, pause, count it down, pause, count it down, pause over and over again. Okay. But here's what I need to happen. And this is where it gets a little tricky, but this is where trial and error would be great for you and the kids. You want it to do those other pieces, right? You want it to turn on the buzzer. You want it to maybe show the icon still, those kinds of things. You don't want to put those in else, because they'll not happen at the right time. But you don't want them to keep happening as it goes. So they're going to kind of snugly be right between these little guys. So we're going to do digital write pin 0 on. We want the buzzer to go off. So we go back to input. So we're going to digital write, output. It's an output. We're going to digital write. Okay, right. Can you see I can kind of snugly fit that in here? So it's not in else. I don't want it there, because it won't happen when that if loop, or when that buzzer, or when that PIR motion sensor goes off. I want it right after the repeat. So I want it to repeat through these things and then do this. I'm going to turn that on. So 0 on. So the buzzer will go off. I think it would still be cool to show the icon. Maybe we can do a different one this time. We'll do a heart. And then don't forget, you still need to do the kind of reset. So clear the screen.
Question.
Oh, yep.
So there's 2 identical code blocks on start.
Oh,
writing
good catch.
P0 to low. And is that? And they were just wondering if there was a reason that those were 2 of the same.
Nope, it's wrong. Good catch. I pulled them over and I didn't change them. That's an amazing catch. You want to go ahead and set them both to low, but both means both, as in P0 and P1. So that sets this to low. It just tells it, hey, this is off. This is what off is. And then it sets this to off. Good catch. No, you are totally right. That should be P0 and P1, because those are the 2 ports we're using. Good catch. Awesome. So same thing right here, but we're turning it on. So the buzzer will turn on. It'll show the icon. It's going to clear the screen, and then we need to reset that timer though. So variables, put the timer back to 20. Now, why the else loop? Well, because it wants to know if the PIR motion sensor goes off, this is what I do. But what else? What if it's not? What do I do? You just want to make sure that that buzzer's off. So you want to go back to output, and you're just going to put that buzzer, which is at P0, low. Remember, low is off. And that's all you need for that, because it just needs to know, it's just going to want to know, hey, what do I do if that's not happening? So again, there's about 100 different ways you could probably code the same thing. So feel free to play around and try to code the exact same thing in a different way. But this is something I wanted to show you kind of with those different loops. So before we start it, you have this. That's great. I want you to be able to have that in case you buy one, and you can try this with your kids. To model it really quickly, I'm going to change these again to something that isn't quite so long, so that you can now see. This is a great time to know, okay, did we do it all right? We haven't tried it, so really I have no idea. But up here on the top, you can see start simulation, and it will test your code and do everything right there in real time. So I'm going to click start. I'm going to close my code for a second because it's going to get jumbled on the screen when I do this. So if you click up here, Actually, I maybe can fit both in. Let's see if I can. There we go. Yeah, I can. So if you click on the sensor, you can imitate the waving by taking this guy in front and waving it. Okay. And so now we can see it's counting down, which is what we wanted it to do. Excuse me. And then hopefully it will show the buzzer going off, and it shows it with like little volume things. And if you're, I don't know if you can hear it. It's very small, but it does like, so it's showing you the buzzer's going off. You can't hear it.
No, I could hear it.
Good.
I don't know. It was unsettling.
They're just as unsettling in person. But yeah, so the buzzer went off, it showed the icon and it cleared the screen. So your code works. So you can do this. I know a lot of us maybe are not teaching virtually anymore. We're teaching hybrid, something like that. But the other thing about this, guys, is if you don't have the money to invest in a bunch of microbits for your whole class, you can do everything here, whether it's through MakeCode, so that you have some of those capabilities, or through TinkerCAD, which opens you up to so many different inputs and outputs. That was a lot, but I want you to have time to, I want to have time to quickly talk about a couple projects and have time for questions. But before I stop on this screen, were there other questions? That's a lot to take in. Again, it's just all about playing around with it. You don't have to be an expert. But hopefully you took something from it. Okay. All right, I'll leave it up so I can come back. And it is in here. So you have it.
Sorry, we did have two questions.
Okay.
Someone wanted to know about exporting, the export process, and like how you save this.
Oh,
and then
okay.
Yeah, go for it.
I have not done that from TinkerCAD to a Microbit. This is new for them. Every time I've coded a Microbit to do that, I have so apparently, I'm not sure. If somebody else has done TinkerCAD straight to a Microbit, I would love for you to jump in. I do know you can save your code right here by downloading it. And so it saves it here for me, but it has to have a way to read it. So you have to be able to put it into a different reader. I have not done that from TinkerCAD to Microbit yet, because like I said, this is a new feature. But here, it's actually very simple. Two different ways. One, you literally plug your Microbit into, let's say the kids have Chromebooks or things like that. It'll see it as almost like when you plug in a thumb drive, and then you click download. And if it's an older one, you just take that file and you drag it to the Microbit like you would drag something to a thumb drive or a folder. Okay. If you have the newer ones and a computer who can use the Bluetooth, they will actually Bluetooth sync to them. So if you click download, it'll give you the different options of how to do it. It just depends on which ones you have and if your computer is capable of talking to it. So if I were to power this guy on, I could try to just pair it and it'll Bluetooth sync the code to this. But I have not done it from TinkerCAD. Did anybody put in the chat maybe the best way to do that? It's just so new.
Well, you can download a hex file, and there is a save, but so you can download the hex file. Exactly how, I don't know, Brian, how you would upload that. You want to share?
Sorry, I can jump in. It's the same, right? You just drag and drop it. I think I just did it. I have nothing hooked up, but it looks like it's the same process. You just drag that hex file over to the Microbit.
Awesome.
Oh, cool.
So you guys see down here my hex file downloaded. So what he's saying is you can just show in folder. And if I had the Microbit plugged in, I could actually just pull it over to Microbit to upload it.
Just like when you drag a file onto like a USB that's like plugged into your computer. Sweet.
Exactly. Thanks, Brian. You're the best. Also, shout out to Brian. These are his images right here that I showed you. So
Brian's our wizard.
What was the other one, Kelly? Did I answer both? I don't remember. I didn't want to leave anybody.
I think that was it.
Okay.
Yeah.
If there's more, I can come back. I don't want to leave anybody.
Someone did say that they didn't know, they had never seen this tool in TinkerCAD before, so it's very helpful.
Yay, good. And if you want to mess around, there's a bunch of Arduino boards and stuff like that. They also have lessons and not microbit lessons, but they have lessons on like how to learn how to use a resistor, how to light up a light bulb, things like that in TinkerCAD circuits. TinkerCAD circuits is new to a lot of people, but it is so versatile and amazing. Awesome. And it is not limited to block coding. So it actually also does, you know, like I said, the Arduino IDE. All right. I'm going to go back here really quick. Feel free, Kelly will jump in and ask me questions. If you want to learn more about TinkerCAD, if you haven't used it before, we were in the, I'm going to do this really quick. We were in the circuits. TinkerCAD also, that's where it got its CAD portion. It's just similar to, it's the child version of AutoCAD. So it's just allowing you to do that computer design. And so I have a bunch of random stuff in here, but if you want to learn more how to do the 3D design elements, they're going to have a lunch and learn, which I just think is an adorable name. And that's also in your, slide deck. So you can go and look at it later, but that's going to be on Tuesday, March 30th, it looks like. So that'd be something fun to hop into to learn about the 3D design.
I'll drop the link in the chat as well. And then, I think the slides are actually not on Padlet, but I'll add them in.
Oh.
And then, but here, I want to drop the link for registering the 3D design. I think most of y'all were saying you have used that for TinkerCAD, but if it's something you haven't done yet, we're going to talk about it. And then we'll have another lunch and learn a few weeks after that, teaching how to use Onshape, which is an even more sophisticated, but still student-friendly 3D rendering tool.
Especially if you're high school.
Yeah, high school, I'd say, is probably good for Onshape. One person said, could you show the breadboard connection on MakeCode once more?
Oh, yeah. So it only seems to pop up. This is, again, I'm totally being honest with you. This is a new feature I just recently found. The only reason I found it is because of this woman I'm going to talk about here in a second. She made this adorable little ticklebot that I have been trying to make. And when I realized, Brian's laughing because he knows what I'm talking about because it went viral. When I realized that it did this, it was because I was actually coding and MakeCode servo motors. And so anytime you're going to have those servo motors or probably any external like large components, notice I'll give it an input real quick. So on button A pressed, when it sees me begin to code a servo motor, so I'm saying on this button A pressed, send that servo motor to 180 degrees. But notice it was already set to that port 0 and it did it over here for me. It set it to port 0 and it already has it power and grounded. But when I end up putting, I had to have 2 for the ticklebot because his arms go like this. So if I put another one over here and say it goes to P1, it's actually going to start coding or, oh, sorry, I digital right pen not. There we go. It's going to like map out that breadboard for me, which is amazing. And I don't know if I've just never noticed or if this is new, but I think that's fantastic because it helps kids kind of get that wiring down from the beginning. So you can see this is obviously the P1 because there it is going to P1 and it's being powered and grounded. And then you can have them test it out with, okay, here's 90. So if I go over here on button A press, one goes to 180, one goes to 90. But yeah, that breadboarding feature, unless somebody knows other than me how to make it pop up, it's just because I made it understand that we were about to use servo motors. So it pops up for you, which is fantastic. That's just amazing. But that's how I made the breadboard come up. So hopefully that helped. Sorry, I'm going to do this real quick.
Someone wants to know, are you going to build something for the hashtag Microbit virtual parade?
That's so funny. I was going to tell you all about that. So I'll go there really quick. So if you don't follow this, if you have a Twitter, I highly recommend you follow this lady. She's very cool, has done a ton with Microbit lately, but she just has some really cool STEM videos and tweets. Highly recommend. I'm very overwhelmed right now. Like I said, I'm doing my master's and I teach 2 different courses at school and stuff like that. So honestly, I have not done something for the Microbit parade, which is very sad. But my colleague she's trying to make a horse that with servo motors and popsicle sticks will look like it's galloping across like a field. which is super cool. But yeah, guys, go check out this hashtag Microbit virtual parade, because then you can see all these cool things people are building with just microbits. They seem so small, but they can do so much.
And so
you can
is
go
the
see all
idea
these
that they're going to like stitch it all together in a video and it's going to be this cool parade?
I hope so, because look at these. I hope they do. I do have a friend who teaches at the middle school I used to teach at, and she did a parade. I'm not sure if she did it with microbits or Arduino, but they made moving objects and they paraded them down the hall. So it's something you could even just do with your kids. So definitely go check out these, because they're all these amazing. Oh, that's a Ticklebot in the background, I can tell you right now. There's all these different amazing things that you can see microbits do that, I mean, if you're new, it's probably very eye-opening too. Oh my gosh, I didn't know it could do that. But yeah, check out hashtag Microbit virtual parade. It's awesome. And then Jasmine. Okay. So no, but I haven't made one. I feel left out.
Oh, it's still a Lamar Brown mystery person, but somebody's project was you just showed.
Oh, really? Oh,
yeah.
Man. Oh, that's amazing. Wait, which one is it? I can try to
Andrew
highlight you. Oh, where's that hashtag? So I just click it. There we go. That's so cool. So you have one done. Eric, Pauline. Tell me if I miss it. Andrew. Oh, Andrew, here we go. So cool.
What? That's insane, Andrew.
That's amazing. That's very, very, very cool.
It's a work in progress, but it looks amazing.
Yeah, that's a hefty work in progress. That's awesome. That is amazing. Yeah, I'm embarrassed to say I don't have anything for the Microbit parade. I'm so sorry. I have too many hats right now. I want to leave you with a few things. These are all, again, obviously in the slides. I've linked to the tutorials. I've linked to lessons. This is not like tutorials. These are literal lessons that you can do with the kids. They have some really amazing ones. Actually, why did I do that? Because it's been a long day. There we go. There are lessons that you can do with kids on a variety of different topics, including even some science, health, all that. You can do it by age groups and whatnot, or by different subjects. There's also Instructables. If you've never been to Instructables, I love going there to find some really cool things to just do for myself, just some fun creative things. So if you want to do something for you to get a little more comfortable, go to Instructables, because there are a ton of really fun projects. And then TinkerCAD lessons, they also have their own lesson plan area. I don't think it's quite as robust. They're probably working on building that out, but definitely check that out. Just want to leave you with a quick couple ideas to kind of get those creative juices flowing. So I wanted to first focus on real world problem solving, because that's what, Project Invent does. That's something I'm passionate about. But if you have not checked out the global goals for sustainable development, it's a great place to start. Those are very big goals, kind of what Kelly was talking about with, solve world hunger. If you're a high school teacher, I help those kids kind of take those goals and narrow them down to smaller goals, or you could do that for them if you teach younger kids. But there's an entire Microbit dedicated page to problem solving the global sustainable development goals. And then I found this really great teaching blog post on that, where she had them make different, like this was a sea turtle machine that goes around and sucks up trash, or somebody wanted to do class. I mean, it's all about them solving problems they're passionate about. I also have given you some ideas just based on your topic area. Let me just think of a couple here that I can talk to you about. Oh, one of my favorites that I did do, the reason it's not linked is because it's something I did, but whether this isn't Microbit specific, you could do it with really anything if you have a digital fabrication lab. But if you're an English teacher, my biggest beef was not with you, but with when I first integrated the lab, a lot of teachers were like, that's a math and science thing. That's so not true. It can be anything. So very quickly, we had the students read a novel that were out of these select 5 or 6. All of them had some major event that changed the trajectory of the story. One of my favorite ones from this was a middle schooler. So this is an 8th grade student. It was a book, which maybe you English teachers will know. I don't know it off the top of my head, but somebody steals a stop sign and there's an accident that causes the death because of it. So the student created, using a microbit, a button, and a piezo buzzer, a way to have it to where the would sit between the stop sign and the like, you know, pole that it was on. And so when the button's pressed, everything's fine. But if the stop sign were to be stolen and the button is not pressed, that alarm would go off. And so they created that invention, and then they had to rewrite the ending of the story based on that invention. So if you're just creative, you can do this in any classroom. But there are a ton of ideas on here that are all linked. Otherwise, there are probably things that I have done, which I'm just out of time and I don't want to keep you guys, but you can make interactive maps. We made maps that had a bunch of LEDs. So when you push something, it showed like a Civil War path or something like that. But I think the rest are linked so you can look at it on your own. Okay. Are there any other questions, things I can leave you with? I hope you took something. I know that was like speed race through, but hopefully you left with something useful.
Yes, and if you need to go, it's 2 minutes past time. So, which really good timing, Maddie, because we packed a lot into that. Thank you so much. You guys were amazing. If you do have any questions, feel free to drop them in the Padlet, and we'll take a look at that over the next day. I'll send out the recording tomorrow so you have it to reference. Cool, yay. Check out the chat. Everyone's enjoying it. Oh, that's so nice, Jessica. Thank you.
Oh, good. That makes me so happy because it's hard virtually. So I'm so happy. That's awesome. Good, good, good.
Awesome. If you're a high school teacher, please register for the fellowship. We want anyone that's interested in this stuff. We want to meet you. So
yay. Yeah.
Awesome. Cool. All right. I think we will log off so everyone can get to their evening. Thank you so much.
Hope your day gets better, Susan.
Yeah.
Yes, nice to see you, Brian. I agree with Maureen.
Thanks for coming, Brian. Tomorrow the recording will come out to the person that asked. Oh, real quick, the Padlet, I'll drop it one final time.
Yeah, okay.
I have it, yeah. Goodbye, all the Lamar Browns. That was so fun.
Many
Awesome.
Lamar Browns.
So many. Okay, cool. Maddie, thank you. You did a great job. Bye, everybody. Gonna close out the room.